Good morning, dear professors, colleagues, friends. My name is Oleg. I'm a second year PhD student at Civil Engineering Department. And my research and interest is focused on water management, sustainable development, and in more broader sense, it could say like safety, environmental safety, technological engineering, in some case, mental safety. So I would like to start with how to live safe in unsafe world.
It's working now.
And every day we are reading some accident, disasters happen, people are suffering, animals, and what to do, what we can do, and what is the reason when the safety becomes unsafe or unsustainable. And one would say that the reason is the chaos, or in more thermodynamical sense, entropy. So I would like to go to the beginning of the entropy and the beginning of the universe. So the very first event in our universe was chaotic, when the void was disturbed and the universe started with the Big Bang, and there was inflation. So the reason why the universe exists and we exist is the chaos. And as we know from the second law of thermodynamics, the chaos will only increase. So there is no way that we would make it decreasing. So, and what we can do with this if the reason of our sufferings is in our own existence. So some scientists tried to tackle with this. Ludwig Boltzmann, he was one of the founders of thermodynamics. He introduced the term of entropy in academic vocabulary, but he couldn't tackle his own case and he ended with suicide. His successor, Oleg, his student, he was going on with these studies, but unfortunately he ended the same. Alexander Friedman, he was studying the Einstein's equations, and he developed the concept of the Big Bang, that the universe started from one single point. He was good, but he ate unwashed foods on the railway journey from his honeymoon and died, unfortunately. And to be more positive, Andrei Linde, who introduced the inflation concept of the universe, he's okay. He's 76 now and professor of physics at Stanford. And one of the modern concepts in science is called age of chaos, where we don't want to live in the full corner to the level of the where every event is predictable because it will be very boring or autocratic, but we don't want to live in the full chaos where there is no rules, everything is unpredictable. We want to live something in between at the age of the chaos where the unwanted events are predictable and wanted events are happening in some period of time or chaotic. And I like this idea very much because it's like not new knowledge. It's very old knowledge from Eastern philosophy. I think it's called in the Buddhist middle way. When we go in the middle, it's very hard to go. Or in Tao, it's like a yin-yang concept where everything exists in other opposite terms. Going later to semiconductor industry where the physics could employ high performance computations, there was introduced lattice gas cellular automata, where the idea here is that starting from one single point in a row and using some primitive binary rules, we could develop the whole complexity structures where researchers find patterns, they are evolving, they are developing, so it's not like 100%, but sometimes, in some sense, it proved that it's possible that the universe was developed from the one single event. And going to my own struggle with chaos, um, I propose the simulation on rainfall events which affect the railway track. And usually it was very chaotic process. So all the simulations and models are based on some very raw approximations and empirical statistics. So my proposal is to use this chaos with the latest Boltzmann evolving model so that we could track the hydrodynamics in the railway ballast and predict some unwanted environmental effects. Like to start my research, I generated some chaotic rocks in 3D, in 3 dimensions. So after that, I formed the ballast layer of the railway track, and the most advantage here is that these 3D rocks are printable, so we can use 3D simulation and print its twins in physical world and to make the model very accurate to our real world. So this is the screens of my 3D simulation. So to the left, you can see that it's like screen of the rainfall effect on the railway ballast. To the left, you can see like generated railway track. And I hope that later it will be possible that we will realize it in some physical stuff and use it in our lab to and use it in our lab to fill this domain with generated in 3D real ballast and to spray from these drenchers some water to simulate rainfall effect. And my hope is that in this chaotic pattern we could find a good convergence. But it's only my hope, and let's see. And go back to the topic of this of my announced presentation. It was like the first struggle with chaos when we tried to deploy the open source and public available data as well as software to predict the effect of railway tracks in central Chiang. But we did not predict that the central Chiang Mai, where the railway station is located, is very flat, so we didn't achieve any flow on this terrain. Because you can see on the left it's very yellow, so the terrain is flat, there was no flow. And to check ourselves, we tried to employ it on the mountain terrain in eastern Chiang Mai. And as you can see, we determined watersheds on this area with a high difference of terrain. As you can see, this is central Chiang Mai, this is the eastern suburbs with mountains, and we found the exact area of all the watersheds, and we generated some flows. And the idea was that we made the first try ourselves, but then I'm trying to go in depth to employ more modern and high performance computing techniques to predict some negative events. So, and to reach sustainability. So I hope that my presentation will give you some food to think how we can deal with the chaos and make our world more safer and sustainable. Thank you very much.